Good morning once again, and welcome to next class of control systems. So this is Dr. N. Ravishankar Reddy, working as associate professor in Electrical and Electronics Department, G. Pullard Engineering College, Kurnool, Andhra Pradesh. So last sessions you are seen about the main types of control systems, then difference of the closed loop and open loop control systems, then mathematical modeling of physical systems, that is translation systems and rotational systems, then electrical systems, that is electrical circuits, then how to convert the electrical mechanical systems to electrical systems. Okay, that is called analogous systems, right? So that is called force voltage, force current. Similarly, torque voltage, torque current. No, like so. Now today we class with the reduction techniques of the block diagrams. So this is the important topic in this chapter. So block diagram reduction technique. Right? So basically, block diagram is a pattern, that is a pictorial representation of the given system. So it is very simple and way of representing the complicated practical system. So in block diagram, the interconnection of system components to form a system. So it can conveniently shown in blocks arranged in proper sequence. Okay. Then draw the block diagram of a practical system. Then each element of practical system represented a block. Then the block is called functional block. Then it means the block explains the mathematical operation of the input by the element to produce the corresponding output. So the actual mathematical function is divided by inserting the corresponding transfer function to the element inside the blocks. Okay. So these are the simple blocks I taken, that is closed loop control system I taken. So here this is the summing point, right? This is the summing point, right? So this is the summing point here. Yeah, summing point. Then this is the forward gain. Then you go to the feedback, that is called as a feedback system given to the input. So R sub is the input, that the excitation called, then CF is the output. So what is transfer function? Transfer function is the Laplace transfer of the output by Laplace transfer of the input. Okay. So this is the simple form of the representative of the closed loop system, right? So what is transfer function? What is transfer function of this closed loop system? So very simple. So what is in this case? Right. So in this case, so C of S. So this is the G of S, then C of S, then H of S, R of S, right? So this is the error. What is the error between the output and input? So comparing the difference. So here may be positive feedback or negative feedback. So depending on the system. Okay. So now consider. So what is E of S here? E of S equal to RS plus or minus C of S into H of S. Okay. Then what is C of S? C of S is nothing but C of S is the E of S into G of S. C of S equal to E of S into G of S. What is, so therefore E of S equal to C of S by G of S will get. Okay. So C of S by G of S nothing but, again we take C of S by G of S. Okay. So then coming to here, first equation, so take the first equation, this one. So R of S plus or minus C of S to H of S, right? So R of S, C of S, H of S. So in this equation, just to substitute the what is C of S. So from what is C of S? C of S equal to E of S into G of S. So E of S and G of S substituting here. So now take the C of S. C of S multiplying here, G of S into R of S, G of S into R of S. Right? Take the common, which is common in this case. So take G of S and G of S, take the common here. So take C of S is common. So 1 plus G of S into H of S. So R of G of S as it is. Now take the output by, that is Laplace output equal to C of S into 1 plus G of S into H of S. So we can see these two block diagrams now reduction to only single one. Okay. So G of S by 1 plus R by G of S. If the feedback is negative, so here you will get a 1 plus G of H of S. If the feedback is positive, then you will get 1 minus G of H of S. So that is the only difference in it. Okay. So already I represented here. So plus sign for negative, that is the positive feedback. Okay. So here the is positive. So this is the simple technique to reduce the that is closed loop transform to single block. Okay, so this is closed loop transfer function. So generally this is called as a Cauchy equation. So 1 plus G of H of S is called a Cauchy equation, right? Right. So what is the different rules for reduction of block techniques? So there are 8 rules are there. Okay, so what is the first one is the cascading the blocks in series. Okay, when blocks are in series, that is the G1 G2 of S. So how they get the final one? So you have to combine these two blocks. So what you get G1 of, so multiplication G1 of and G2 of S. So proofs also getting here. So y of s equals, so now coming from the first block. So y of s equal to only one y of s, g1 of s into r of s. What is c of s? Y of s into g2 of s. So, okay. So c of s, g2 of into y. What is y of s? g1 of s, g2 of s. So substitute here g1 of s, r of s. So at the end you will get c of s equal to g2 of s, g1 of s, r of s. Okay, here also you can see c of s equal to g1 of s into g2 of s into r of s. So this equation same, this equation same. Okay, both are same. So we can multiply the when the blocks are in series, then multiply the individual gains. Multiply the individual gains, you will get the single block. Okay. Similarly, we will go to the second one. Right. Now see, cascade blocks in parallel. So previous case the series, now it is the parallel case. So G1 of S, G2 of S. Okay, connected in parallel. So with the summing point. Okay, this is called a summing point. Now input is the R of S, output is the C of S. So in this case, what is, let us take Y1 of S, Y2 of S for the individual blocks. What is Y1 of S? Y1 of S is equal to R of S into G1 of S. What is Y2 of S? R of S into G2 of S. So at the end, what is C of S equal to? C of S equal to Y1 of S plus Y2 of S. Okay. Then substitute the individual gains. So G1 of S plus R of S, G2 of S to R of S. Okay. Now G2 of S, here R of S the common, take the common. So G1 of S plus G2 of S. Okay. So here we have to add the individual gains. So previous case is the multiplication of the individual gains with the adding. Okay. So at the end, C of S equal to G1 of S plus G2 of S into R of S. Okay. So when you get the two blocks in a parallel with summing point, or it may be different sometimes may be different, it may be plus or minus. So depending on the sign, they can change the sign. Okay. So here G1 of S plus G2. Suppose this is minus is there, so take the minus here. Okay. So this is the simple rule when in a parallel, then it's converted to single block. Okay. Then again to other one. So this is the closed loop transfer function. Closed loop. So G of S into H of S. Already you have seen previous slide. Okay. So G of S, H of S. So G of S is the forward gain. Then out that is the then C of S is the output. So H of S is the feedback. Then R of S is the input. E of S is the error between the output and input. Okay. So D of S. So same you can observe the here the proof also you can see here. Same previous one already you are seeing the closed loop transfer function proof. Okay. What is the C of S? C of S equal to E of S into G of S. Okay. What is E of S? E of S equal to B of S, R of S minus B of S. You can see here R of S, B of S. Right. Then what is C of S equal to command? So at the end, substitute the in place of C of S equal to G of S into R of S. So substitute here. What is R of S? Substitute here you will get. So take the common G of S. So again you will get the same thing. So C of S by R of S equal to C of R of S, G of S into 1 plus G of into H of S. So same thing here. So C of S equal to C of S into. So what is the output transfer function now? C of S by, so we take the R of S here. So C of S by R of S equal to G of S by 1 plus G of into H of S. Okay, same. Okay, previous polar transfer same here. Then again. Then moving the takeoff point. What is takeoff? You call it before the block. This is takeoff. This is called takeoff point. This is called takeoff point. Okay, so moving the takeoff point after the individual gain. Now you want to shift the gain here. So what is the rule? Now you can observe here. So this is the R of S input. Okay, you are taking the input to this side. Okay, C of S and Y of S. So what is Y of S? Y of S equal to R of S only. Now I am shifting this takeoff point to after the block. Now I am shifting after the block. So actually previous case Y of S equal to only R of S. But when you're shifting here, again G of S will multiply with the this block. So when you multiplication again you have to go dividing. So divide the same value, will get the only Y of S. Okay. So you can observe here. So what is C of S? C of S equal to R of S into G of S. Y of S into Y of S equal to R of S. Now coming to here, you can observe after shifting. Now we are add the 1 by G of 1, add the block in this root. Okay. So 1 by G of S. Now You can see what is C of s? C of s equal to G of s into R of s. Same. You can observe this same. Now coming to here, Y of s equal to G of s by divided by G of s, and G of s will be cancelled into R of s. Okay. So what you will get here? R of s into G of s divided by G of s. So automatically G of s will cancel. These two cancel. So then we will get the R of s only. Okay. So Y of s equal to C. Y of s equal to R of s. You can prove here. So this is the way. So when you shifting the when you want to shift the pickup point after block, you have to take the inverse of the that gain, inverse of that gain. So 1 by G of s. That is the only thing here. Okay, keep it in mind. Okay, so if you want to shift the after the block, then take the 1 by that gain, inverse of the gain. You add the one block to in this forward part, second part. That is the only. Then before the block, one thing is there. Now, so you can see. So now it is the block here, the backup point. I want to shift the before the block. What will do? So now just just to see the proof. So what is C of s? C of s equal to E of s into R of s. Clear? So what is C of s equal to? C of s equal to E of s. What is E of s? R of s into G of s. Okay, so you can see here E of s equal to R of s into G of s. Right? What is C of s equal to C E of s? E of s also same, G of s and E of s. Now what is Y of s? Y of s equal to E of s. What is E of s? E of s also G of s, and that is here the C of s is equal to at the end G of s into R of s. Similarly Y of s equal to G of s to R of s. Then and now I want to move this pickup point before the block. What will happen? Okay, now before the now you have to add this block. So when we shift the pickup point from this place to this place, then you have to add the G of s. That is the, if in forward part you add the one. Previous case is the inverse 1 by G of s. Now in this case G of s, only G of s. In previous case 1 by G of s. Now it is a G of s. Okay. Now check the proof. What is output now? So C of s equal to R of s into G of s. R of s into G of s. Then similarly Y of s equal to R of s into R of s into G of s. You can observe here same, right? Same, right? So same value you are getting here. So you observe. No? So only the thing when you shift the pickup point before after. When you shift the after, so 1 by you have to multiply the in forward 1 by G of s. When you shift the before, then G of s multiply with only G of s. So in this case the inverse that is a 1 by G of s. Okay, here the only G of s. So that is the difference between the pickup point when you shifting the after and before. Okay. Then the same thing, same moving the summing point. So moving the summing point before and after. So moving the summing point before and after. Now take this summing point. Okay. Now I want to shift the summing after this G of s. Okay, after G of s. So before that, what is the value? G of s equal to Y of s into G of s. C of s equal to Y of G of s. What is the Y of s equal to? R2 of s. R2 of s. Okay. Then R1 of s. So these are two just adding R1 of s plus R2 of s is the Y of s. So observe here. R2 of s or R1 of s is the T of s. Okay. Now what is the C of s equal to? C of s into Y of s. What is the Y of s? R1, R2. Just you will get. So G of s into R1 plus R2. Same thing now coming to here. When you are shifting the after the block. So summing point of shifting this block. Now what will happen now? Now multiply the two gains in forward path. Multiply the, you add the blocks in this, add here and here. You are adding here and here. That in the forward path, in this all forward path, you are adding the two gains here. Now you can see the proof. What is C of s now? C of s equal to R2 of s into G of s plus R1 of D of s. You can observe here. Now take the common G of s, so R1 of s, R2 of s. Okay, so what is the C of s now? C of s equal to R2 of s, G of s plus R1 of G of s will get here. So here. Okay. So then which is common here? G of s common. Take the G of s common. So R1 to R2 of s, you will get the same. So you can observe the proof is same. Okay. So if you want to shift the summing point after the block, then add the gain in same forward. Add the gain. We add the one more block in this two forward parts. Right? That is the one rule. Then coming to next rule. Now before the block. Okay. Now you can see now the summing point I want shifting the before the block. What will happen? Now observe the proof. So what is C of s now? C of s equal to, so what is C of s? 1 Y of s. Okay. Right. So what is E of s? E of s equal to R2 of s. Right. What is Y of s? Y of s equal to R1 of G of s. Okay. Then you multiply. So here you will get to R2 of s plus R1 of s plus G of s. R2 of s plus R1 of G of s. Okay. So now the G of s same we will get. Then coming to here, we are shifting the block after the summing point. Okay. before the block. Now here, in previous case, what you have done, you are just here multiplying the 1 by, you are taking the reciprocal of the gain. Okay, 1 by j of s. Okay, 1 by j of s here. So actually previous case, you do 1 by j of s, the value is same here. So what is e of s now here? 1 e of s equal to r2 of s by j of s you will get. What is b of s? R1 of s will get. Then what is y of s equal to e of s plus b of s. Just substitute what is b of s, what is e of s. So R2 by j of s plus R1 of s. Right? See, substituting. At the end, c of s equal to, what is c of s? Y of s into j of s. What is y of s? What is y of s? R1, R2 of s by j of s plus R1 of s. So you just adding, so cancel, you will get here, cancellation. Then at the end, j of s R1 plus R2s. So you can observe here, same value you will getting here. Same value. So that is only. So when you, after, before the block, previously you are adding, now in this case 1 by j of s, reciprocal of the gain, adding the in forward part, remaining part is same. So that is the shifting of the summing point before and after the block, right? Next rule you can see. Then this is the dividing. Just you can observe these are splitting the summing points. So here plus plus minus is there. I am splitting. So what is the c of s now? C of s equal to R1 plus R2 of plus minus R3 of s. Why? Now I am splitting in two parts. One is a plus plus one side, then another maybe plus minus. Okay, see the proof. Now what is this in c of s? C of s equal to y of s minus R3 of s. What is y of s? R1 of plus R2 of s. Okay, in place of one, so substitute here. So you get the same thing. So what is y of s? Y of s R2 of plus R1 of s. Substitute here. What is the again here? Minus R3. So minus R3 came in. So you can observe the same thing here comes. So before after the value of the value must be same. Before and after the output of the value must be same. That is the only rule in this block diagram technique. Now joining the summing point. They are given two summing points are given, joining summing points. Okay, they also can observe. See what is y of s, R2 of s plus R1 of s. Right? Then what is c of s? Y1 of s minus R3 of s. Come to this case, so you are combining you are getting. So combining also can see R2 of s plus R1 of s plus minus R3 of s. Same. Okay, so these are the rule. Coming to next one. So these are the moving the take up point after and before the summing point. So take up point before and after the summing point. Okay, before after summing point here. So before and after. So you can see here. So what is c of s now? In this case, what is c of s equal to this R of s minus y of s. Clear? What is R1 next coming to here? What is R1 of s? R1 of s R2. Both are same here because here R1 both are same. Now I am shifting the summing point. Okay, here I am summing point. Now you can see now summing point coming to here. Okay, and before the now coming by here. Then add the in again this path. We add the again this path, but with the sign that plus and minus. Minus also is there, so only plus and minus. See now the proof. What is c of s equal to? C of s equal, what is now c of s equal to R of s? Same here, R of s minus y of s. Okay, so R of s minus r plus or minus, what is it? Y of s plus R of s. So y of s will cancel, you get that end only R of s. Y of s cancelled here, minus y of s plus y of s. So we can cancel both here, you will get R of s. So R of s will be same value. Okay, similarly, same way in before the summing point also. Before the summing point also, same rule. Okay, so plus and minus here, now we are shifting to reverse. So take the opposite. So plus and minus. Here plus and minus there, no plus and minus. Okay, now here also same value will get. So c of s equal to R of s minus y of s. Then R1 of s equal to c1 of s. Then R of s and y of s. Right? So similarly here also, what is c of s? R of s minus y of s. Okay, same value will get here. So at the end, what will get here? R1 of s minus y of s. So coming here, y of s will cancel out. So at the end, you will get the R of s, y of s. So same value. So before after summing point must be keep in mind. So these are the rules for block diagram technique. Okay. Then exchange the two or more summing points. You can also exchange the summing points. We can exchange. You can observe here plus plus. Here plus minus there. You can exchange these two also. You can exchange. After exchange also, the value must be same at the output value. Right? This is the one rule. So these are the rules of the block diagram technique. Now coming to a simple example, so you can observe here. Now see in this problem. Now keep it in mind that whenever the block diagram must be direction from your right side. Okay, if from your right side you have to reduce the blocks, not from left to right. It is a right to left. Okay, right to left you have to reduce the each blocks. You have to reduce technique. Okay, right to left, not left to right. Right. So now you can observe here G3 and G2 are in parallel. Okay, When you get parallel, what is going to get? Addition. When you cascade, it is multiplication. It is in parallel, so it addition. So simple is there. So what will you get here at the output of this one equal to G2 plus these two. So single, this one converted to single one. Okay. See. So now you see G1 plus G2 G3. Okay. So previous diagram. Okay. So previous diagram is converted to only single diagram. Okay. G2 plus G3. Then simple will get G2 plus G3. Again you can observe here. This is inside one closed loop. Inside one closed loop. Okay. G1 and G4. So these are in series. So G1 G2 will come here. G1 G4. Keep it as it is, this one. Then again this is the simple feedback. Okay, this is one simple closed loop. What is closed loop will get in closed loop? What is closed loop transformation? C of S by R of S equal to G of S by 1 plus G of into H of S, right? So these are combination you get here, G1 G4. So what you get here? G1 G4 divided by 1 plus G1 G4 H1 you will get. So these two inside closed loop converted only single block. Okay, so you can see combined here, already combined. So G1 G4. So it depends upon the plus or minus. What is there here? Here plus is there. So you get the minus here. Minus. Okay. G1 G2. Then 1 minus G1 G4 H1. So these two in series. Again cascade. Series. Series means just multiplication. Okay. G1 G4 into this value. G2 G3. So G1 G2 into G3. So same value. Again this closed loop one. Again this is a closed loop transfer function. Okay, closed loop means suppose this is the G of S. So what will you get here? G of S divided by 1 plus G of S into H2. Okay, so in place of G of S you will get this entire value. So then entire value plus 1 plus G of S, this entire value into H2. Now simplify the equation. Take the LCM, simplify the equation. Then you will get the transfer function of the block diagram. See how this very simple technique. So this convert to single transfer function. Okay, block diagram. So again take another example. See here. So it is the feedback there. So you can observe here the one closed loop here, G2 H2 with negative. What will you get here? G2 divided by 1 plus G2 into H2, single one. Okay, so you can observe here. So single one you already got. Now see. So what is there? So here the pickup point is there. So here pickup point is shift to this pickup point. You not disturb this one. So you are shifting to this one. We are shifting the pickup point. Okay, so pickup point was shifting, right? So shifting the pickup point here. When you shifting here, what will happen? So before it is only a multiply with the G1 only. When you shifting here, you have to multiply with the same value. So in feedback path only G1 will have to come. But when shifting here, this value G2 plus also will add to this one. In that case, what will happen? You have to divide the 1 by G2 and 1 by G, you have to divide this value. Okay, so 1 by G2 by 1 less G2 H2. What will happen now? 1 by divided by. So 1 by G2 H2 into H2. So multiply this value. So the value came here. Okay, so you can observe here. Okay, actually there is no, in this part, you have to only multiply the G1 and H1. When you shift the pickup point, you have to add with multiplication, add this block also must be add. Actually before only H1, but after the pickup point also you have to go only H1. In that case, what will happen? Reciprocal, this gain must be added to must multiply to this H1. So that is done here. Okay, can observe. So that is done here. So H1 into 1 plus G2 into H2 divided by. Now take this entire one closed loop. So these two are summing point. So this is the feedback point. So this is the only unity feedback. You can observe here unity feedback here. So that's unity feedback will come to only, so G1 G2 1 by G1 plus 2 divided by 1 plus, so the unity feedback 1 into G1 G2 1 plus G1. So the one closed loop transform here, this one. So that becomes G1 G2 1 plus G2. So this entire closed loop converted to only single block. Again one feedback here. Again feedback here. Again convert to G of S 1 plus G of H. Again convert to this. So G1 G2, so 1 plus G1. So after simplification, again you will get this transfer function value. Observe. Okay, G1 G2 1 plus G1 G2 H1 H2. So 1 plus. So again we will get the all value. So this is the simple way to convert the reduction biology to single transfer function. So this is the another example. Okay. So next class you will see the if possible I will give more problems, otherwise we will go to the signal flow. Okay, thank you.